Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on UPSC previous year's paper. So in this video I will discuss the Civil Service Maths 2018 question paper. So you can read this instructions and comes to the you can read some constant which may be needed. So all are given that. So first question is here. The wave function of a particle is given as phi x is equals to 1 by under root a e power minus x a. Find the probability of locating the particle in the range minus a is less than x is less than a. And question number b is here. Calculate the 0-point energy of a system consisting of the mass of 10 to the power minus 3 kg connected to a fixed point by a spring which is stretched by 10 to the power 2 meter by a force of 20 by 1 Newton. The system is constrained to move only is one directions. Question number C is here. You can see this. The general wave functions of a harmonic oscillator one dimensional are of the forms un x summation k is equal to 0 infinity a k of y e power minus 1 y square by 2 with y is equal to under root m omega upon by h cut x and the coefficient a k are determine the recurrence relations. So a k plus 2 k minus 1 k plus 1 by k plus 2 by a k corresponding the energy level are en is equal to n plus 1 by 2 h cut omega h cut. Discuss the parity of these wave functions. What happens if the potential for x is less than 0 is infinite or harmonic oscillators? And question number D is here. What is nuclear precautions? How is it used in a principle of working of a NMR? So question number E. Calculate the radius of electron orbit of Li plus plus double plus in a ground state. Question number 2a. The ground state of the wave function for a hydrogen atom is sin r is equal to 1 under root pi a 0 3 e power minus r by a 0, where a 0 is a naught. A naught is the bore radius. Sketch the wave function and the probability density as a function of the separation distance r. Calculate the probability that the electron in the ground state is found beyond the bore radius. And question number B. So px ly is equal to minus iota h cut pz and e power minus I sigma n theta cos theta plus iota sigma dot n sin theta. So prove the identities. And question number C is which of the following function is our acceptable solution of Schrodinger equation? So you read this sin x equal to a tan kx. And question number 3 is here. A beam of a particle of energy 9 electron volt is incident on a potential step 8 electron volt high from the left. What percentage of particle will refract back? Question B. So that for free electron gas the density of a state in 3 dimension 3D vary as e power 1 by 2 and the diffidence changes to e power 0 for 2D quantum wall, e power minus 1 by 2 for one dimensional quantum wire, and delta function for 0D quantum dot. And question number C, describe the importance of LS and JJ coupling in atomic spectroscopy. What are the experimental evidence of their existence? Question number 4, what is Given effect? Discuss the factor on which Lemur frequency is dependent. Question B, discuss the fine structure of hydrogen spectrum. How is it of the importance in the astronomical observation? Question number C, discuss the theory of rotational and vibrational spectra of diatomic molecules. What is the difference between fluorescence and phosphorescence? Question section B is here. First question A, nuclear force are mediated by exchanging of pi mesons of rest mass 114 mega electron volt. Estimate the range of nuclear forces. The maximum energy of a positron's E pulse released in the decay of C613 atom into a 7 nitrogen 13 atom is 1.202 mega electron volt. It the mass of the carbon 613 atom is 13.003354 U. Calculate the mass of nitrogen 713 atoms. Question number C, which of the following elementary particle reaction decay are allowed under the Paris conservation law? If write down the type of interactions and characteristic times which would be processed. So 10 mark is guarantee. 1, 2, 3, 4, 5. And question number D is here. Calculate atomic packing fraction AP and FCC and SCP structure and show that these are mostly closely packed structure. Question number, derive Bragg law of X-ray. Compare law and divide scarce method for a crystal structure. We know that Subr method is Powder method of X-ray diffraction by crystal is very good. We know that. So this scientist name here. So again, next question. Question number 6. Question number 6A 1 and 2. So assuming the neutron proton interaction has a square walls from Br is also B minus 0 for R is less than B. 0 is also for R is greater than B. And the ground state of the wave function neutron nucleus is given as sin R is equal to A sin K R for R is less than B. C E power minus gamma R is equal to for R is greater than B, where K is equal to under root M by H cut square V 0 plus W, and gamma is equal to under root M W H cut square. Here M is the nuclear mass, or W is the binding energy of deuteron, and A and C are constant. So that for just bound state of deuteron, V0 B square is equal to pi square H cut square by 4M. Explain why deuteron is a loosely bound extended structure. And question number B is calculate the kinetic. So first A, pi minus mesons are a rest decay into a micro mesons. Pi minus is a micro, mu minus nu micro. So not micro, mu. So mu nu. So calculate the kinetic energy of micro mesons emitted in the reactions. So write question number C. Write a semi-empirical mass formula of nuclei and on the basis draw mass probabilities of odd and even isobars. What would be the most stable isobar in the each cases? So question number 7. Obtain an expression for the magnetic moment of a nuclei having one nuclei outside the closed core. Use this to calculate the magnetic moment of oxygen 870 nucleus. Question number B. Drive the expression for lattice specific heat and divide model. Find its low temperature limit. Divide Q. And question number 3. What is intrinsic and extrinsic semiconductor? So that in the intrinsic semiconductor Fermi levels line exactly in the middle of the bottom of the conductors band on top of the valence bond. And question number 8 is here. What are the type 1 and type 2 superconductors? Give the example, discuss and the compare Meissner effect, perfect diamagnetics behavior for type 1 and type 2 superconductor. So this is related solely tested Puri and Babbar books. Question number B. What are the operational amplifier? How can it is used to as an inductor? Prove it mathematicals. Question number. Describe the working of microprocessor systems in a block diagram. How is its performance is affected in a pipelined processor? So this 20, 20, 15, 15, 30, 20, 50, 15 mark. So that all is related to this discussion. It for today. Thank you very much.